So NFV is the idea that making those specialized hardware into a program and running on a VM. If you need many, you can just elastically make a cluster of them, and when you don't need them, just you can get rid of those VMs. That's the basic idea of what NFV is. Then, what is OpenFlow? OpenFlow started in 2008, and it started as an experimental protocol in campus networks because people had students and many others had scholars. They had great ideas, but in order to make that idea happen, they have to contact Cisco or Juniper Networks, and then ask them to make them as a firmware and put it in their device. And it took usually 2 to 3 years if they're lucky, but most of them wanted to try something as they want. So OpenFlow started as experimental protocol in campus networks. But the concept of OpenFlow was welcomed in many other situations. So commercial vendors like NEC and Huawei and other vendors started to put OpenFlow protocol in their switches and virtual switches. And the latest version of OpenFlow is version 1.51, and it was released in April 2015. So OpenFlow was considered, I think, de facto standards for SDN, but now for SDN, not only OpenFlow, but many other protocols are used simultaneously, and I'm gonna talk about that in the later slides. But the basic idea was that we were having difficulties with this legacy structure, having control plane and the data plane in one box. And OpenFlow was get out, this control plane and put it in x86 server and make it centralized. And that was really well accepted. And before OpenFlow, they had many ideas like DPI kind of approach, but that was too much of an overhead to innovate the network. And OpenFlow deals with only the first packet of a flow. So it is much more efficient than other approaches. Okay, this is how OpenFlow works. This topology shows 4 hosts, and there is an OpenFlow switch, and your OpenFlow switch is connected to the controller. And H1 wants to talk to H4. When H1 sends a first packet, and the switch looks for a match in its flow entry. If it doesn't have any match, then it sends the packet to the controller. That's called packet in. And controller calculate what to do with this packet in, and it gives an instruction to the switch. That is called flow mod, and that's putting an entry to the switch. And packet out, it's sending out the first packet that it received. And it sends out the packet, and then it also makes a rule. So it doesn't have to ask the controller over and over again and jam the controller. So once it gets the first flow is a combination of your header. It can be a combination of your port in, your source MAC address, destination MAC address, IP address, and things like that, TCP ports and things like that. You can use combination of those as a flow. And once you have an entry, it's not gonna ask controller again. And if your software is smart enough, you can reverse those source MAC address and control MAC address and IP address and make 2 entries at once. Then when this H4 wants to talk to H1, it doesn't even have to ask the controller. That's up to you. So that's basically how it works. But I told you, OpenFlow is not considered de facto standard anymore because 5 years ago, maybe 10 years ago, not 10 years ago, 5 years ago, when we talked about SDN and OpenFlow controller, they only supported OpenFlow as southbound protocol. But now we have so many. We have OVSDD, NetConf, Licit, BGP-LS, and many more. And even you can use what's called YAM modeling to make your own southbound protocol. So I'm not gonna go too much into that for now, but now we have many protocols that support as a southbound protocol. Now, OpenFlow is just one of them. And these are list of interesting SDN projects. Starting from VM, VI managers like OpenStack, Kubernetes, and Mesos. And we have OpenFlow controllers, POX and Vue, Floodlight, and many others. And I highlighted in blue software that are written in Python. And what's interesting is this OpenFlow binding. This is called Loxygen, and when you make an OpenFlow controller or OpenFlow switch, you have to have OpenFlow protocol library. So what Loxygen does is it gets OpenFlow specification as an input, and it generates OpenFlow library accordingly, and it generates Python OpenFlow library, Java library, and C. So, and Loxygen itself is written in Python. So if you are interested, you can go to GitHub and search for it, and it's really interesting. And we have SDN emulator called Mininet that I'm going to show you in the next slide. And we have SDN switch projects like OVS, Indigo, and there are hardware switches that support SDN as well. And this P4 is about making hardware more programmable. And if you are a hardware geek, maybe you can look into that as well. So what is Mininet? Mininet is a network emulation platform, and you can create using virtual switches your topology and test your code. So this is how you run your SDN topology, sudo mn, and you specify the topology and the controller that you want to use. You can use the remote controller, or you can use the controller that is inside the Mininet. And this shows you the topology. And in order to get started, you have to go to mininet.org and download the source code. You can use git clone to download the source code and use git tag to search for available versions. I think the latest version is 2.2.3. And you check out that branch and you install with install script. And this -a option is for all. That's, I think, the easiest way to install your Mininet. And what you can do with Mininet is you can create linear topology with 2 switches, just like this. Or you can specify a tree topology with depth of 3. And I tried depth 5. And it worked fine, but it took a long time, and I was afraid to try That's 6. So if you're daring, maybe you can give it a try. And this is called, you can make your custom topology with Mininet. You can have as many switches or computer hosts as you want. And you can specify the IP, or you can specify DPID as you want. I used this when I had to manage 2 different domains. I had 2 computers connected to a controller. And if you use this automated topology, they're going to have the same IP, same DPID for switches. So it's going to have a collision. So in order to avoid that, you have to remember this and try this custom topology, and that will save your day. Okay, now let's talk about Ryu. It is pronounced Ryu, and it means both flow and a dragon in Japanese. And a friend of mine told me this dragon is long Ryu, so he said it's just flow, and I believe that. So maybe, but it's in alphabet, it's in English, so I don't think that really matters. It's a component-based SDN framework, fully written in Python, and Python 2.7 and 3.4 compatible codes. And it supports many protocols from OpenFlow 1.0 to 1.5, the latest protocol. And it also supports netconf and ofconfig. And the license policy is Apache 2.0. So this is how you get the source code. You git clone and use pip install it. And you can use Review Manager command to run your app. Okay, try to install your Vue on Ubuntu 60.07 LTS or later, and don't forget these dependencies before you install your Vue. And this is my first application that just extended App Manager Vue. And if you want to try something a little bit more complicated than this, you might want to try this dumb L2 switch. Okay, you extend App Manager Vue and you define packet in handler. And this decorator does a trick. This is getting the packet in. This first argument means you're gonna get the packet in messages from the switch. And this main dispatcher means when your switch and controller has negotiated the OpenFlow session, and then you're gonna get packet in messages. And this EV message indicates packet in message format. And this DP, data path, means your switch. And DPoF protocol means your OpenFlow protocol. And this means your OpenFlow parser. And the action you're gonna do is just the flooding. Packet comes in to one port, goes out to all the other ports, except the port that it came in. And you set the action and the data path and every argument, and then you send out this packet. That's basically how dumb L2 switch works. If you want to try something more complicated than this, you can go to the website and try for yourself after this presentation. Okay, it's demo time. I'm gonna show you some demo I have prepared, and it's a very simple one. I'm just gonna run Vue controller, and then connect Mininet, making linear topology first with 5 switches. And then I'm gonna try with tree topology with level 3. And I'm going to show you some GUI tool they have, and I think that's it. That's gonna make end of my presentation. Okay, let me get started. I'm gonna open two connections to my virtual machine in Amazon. I just hope it works. Yeah. It worked when I tried like 30 minutes ago, but it seems like it's not working anymore. Yeah, I still have the internet connection. What's wrong? Yeah, I guess there's some technical situation here. So it's very simple. So basically showing you what you already saw, making this topology, and showing you doing simple stuff like pinging each other. Yeah. So maybe I can show it later, and think this is all I have prepared for today. And if you guys have any questions, I think I can take some questions. If you don't have any questions, I think okay.
So I saw that it's easy to configure in topologies or components with Python, but is there any performance issues like overhead from Python or?
In the beginning I told you that I use Java for most of my work. That's because Python is considered slower than Java right now. So many students use it for academic use. They prefer Vue and POX, Python written controllers, when they use academically. But when they try to make commercial products, they mostly use Java or C or C++.
So you mean it's applicable only in academic simulation and not applicable in commercial solutions?
I haven't seen any solutions in SDN domain that are written in Python for now, but maybe in the future. Okay, seems like that's all for today. Thank you for listening. Thank you.